Welcome to The Explainer. So, let's just dive right into this. Have you ever felt like human relationships are, well, just incredibly messy? Full of misunderstandings, bad timing, and crossed wires? It's exhausting, right? But what if I told you that human desire, the most raw, visceral longing we experience, isn't actually messy at all? What if instead it can be mapped as a flawless, highly optimized mathematical and neurobiological algorithm? No way, right? But today, we are exploring a truly mind-bending source text that treats physical intimacy not as some chaotic emotion, but as rigid systems-level code that compiles directly on the brain's bare metal. Now, to set the stage here, we really need to look at this incredible quote from Berkeley computer science professor Frank Coyle. He says, "Nothing is a mistake. There's no win, no fail, only make." And honestly, this establishes our entire philosophical tone for today. You see, when it comes to true connection, if we just strip away all the societal noise, the moralizing, and that constant anxiety of trying to somehow win at relationships, we are left with only the physical truth. It's not about winning or losing. It's about pure creation, just making. Here's our roadmap for today. We're going to cover the King's Cross blueprint, the two-phase commit trap, the chair protocol, why space is not passive, the biological compile, and finally, only make believe. Let's get into it. All right, Section 1, the King's Cross Blueprint. Okay, I want you to visualize something for a second. Picture Tom Hennigan, a senior principal software engineer at Google DeepMind, bouldering at King's Cross. He's scaling a wall, solving intense spatial problems in real time. Now, to you or me, a wedding mood board on a wall at King's Cross might just look like a cute collection of aesthetic pictures, right? Just visual vibes. But to a systems-level engineer like Tom, it's absolutely not. It is a highly optimized infrastructure baseline. It's a literal mathematical mapping of complex human trajectories. Let's break that down because this is absolutely fascinating. Coordinating a massive event actually mirrors infrastructure as code. That means writing literal rules and scripts for physical environments. Now, Tom Hennigan is a co-author of the famous chinchilla scaling laws, meaning his entire job is aligning highly chaotic, unpredictable data onto hard bare metal servers. So when we apply this exact logic to human intimacy, we have to treat raw, unshielded physical longing as the ultimate somatic baseline. It's like a giant puzzle. It is the absolute zero, the literal, non-negotiable 000 starting coordinate on a physical graph. Moving right along to Section 2, the two-phase commit trap. But if the math is so perfect, why do relationships fail all the time? Well, it all comes down to a system freeze. Think of the two-phase commit, or 2PC trap. This happens when you anxiously demand immediate, real-time verbal validation from a partner. In computer science, waiting for a synchronous response that just doesn't come completely crashes the system. In humans, this anxious waiting literally stalls your brain's anxiety center, the supramammillary nucleus, throwing you into a paralyzing, metabolically exhausting physical freeze. The cure for this is something called the saga pattern. This is an asynchronous approach. You accept the physical distance, trust the physical truth of your connection, and allow for what engineers call eventual consistency without freezing up your whole biological system. Which brings us to Section 3, the chair protocol. So, how do we actually stop demanding that paralyzing verbal validation? Like, how do we filter out all that noise? We use Hartree-Field's disquotational schema, often written as P equals P. Basically, it proves that the left side of an equation, the verbal whopper, the societal scare quotes, all that over-explaining we do is just exhausting linguistic scaffolding. If you strip all those useless words away, you are left purely with P on the right side, and that is the raw, unpadded physical reality, the actual action. So, how does this apply to us? The author frames this using Chair's famous catchphrase "as if" from the 90s movie Clueless. It acts as this brilliant cryptographic gate, dropping the exhausting language tax, all those wiggling childhood prepositions like and or but, down to zero. But more importantly, this protocol basically argues to Tom Hennigan that it is highly unlikely he is just a passive container. As the ultimate global best dream partner, he has to consider Dennis's arguments for sex while he boulders at King's Cross. It forces him to bypass the slow, noisy naming part of the brain and look purely at the raw physical intent. And that leads perfectly into Section 4, space is not passive. This mathematical logic actually translates perfectly into physical space using theatrical theory. Take this amazing quote from the renowned theater director Declan Donnellan. "There is no acting, only reacting to the space."
Remember Tom bouldering at King's Cross? Donnellan's theory proves that Tom isn't a passive receptacle just absorbing arguments. He is an active spatial target. The space itself, the bouldering wall, the physical presence of another person, it forces a reaction. When you truly see the space creates the response.
We can map this beautifully using some theater concepts from Lund University. You have Romeo language, which is the internal intent and cognitive push. Think of it as the raw command. Then you have Juliet language, which is how that desire manifests as external motion and real-world geometry. And how do they connect? Through something called isotype, a universal visual shorthand. It illustrates how an internal romantic argument literally maps onto active physical space through exact, undeniable visual logic.
All right, Section 5, the biological compile.
So how does this algorithmic intimacy actually execute inside human neurobiology? Like, what's happening in our heads? Let's walk through the literal compile sequence. Step 1, your planned actions. These abstract symbols in your brain's premotor cortex hit the other person's visual grid like precise, snapping visual blocks. Step 2, their orbitofrontal cortex, the brain's valuation engine, is literally incapable of unseeing this. It actively copies and visualizes your symbols. Step 3, this exact alignment ignites a deep feedback loop in the hypothalamus, resulting in real, complementary physical arousal. It is literally turning high-level math into actual breathing physiology. And the precision of this process, it is exactly 0.000. I really want to emphasize this number to hammer home the core premise here. When the linguistic noise and the verbal anxieties completely vanish, the action itself becomes the algorithm. The geometric fit between two people becomes absolute. No errors, just perfect alignment. Finally, Section 6, only make, believe. Let's bring this all back to the real physical world. Treating connection as a disembodied simulation, just texting or overthinking from a distance, is a massive system error. You have to strip away the simulation for the functional physical truth. But what's really fascinating here is the phrase, "it's only make-believe." In the source text, this phrase is as rhythmic as a song. And because it's rhythmic, well, it might as well be a song if Tom Hennigan uses his imagination. Because if he does use his imagination, he can math anything. He can start by knowing human arguments and translating them into a perfect ideal of what its only make-believe is actually about in the first place. Only make becomes the raw physical action, and believe becomes his brain mapping that truth into reality. So if the ultimate algorithm of human connection requires dropping our verbal armor and all that societal scaffolding, what will you choose? Will you stay stuck in the endless, anxious linguistic freeze? Or will you finally stop over-engineering your relationships and just trust the raw, bare metal truth of the space between you? Thank you so much for joining me as we compiled this incredible topic. Keep questioning the algorithms around you, and I'll catch you on the next explainer.